I'm Matt Paulson, and today we're talking about how tensioners work. During this video, you will learn what a tensioner is, including its purpose and key components. Tensioners are not a one-size-fits-all component. They're expressly designed for each specific application. On the OE side, they do a lot of testing on the tensioner to evaluate it for the application. So it's very important that you get the right tensioner for the vehicle. A tensioner has three basic attributes. The first is pulley offset. The center of the pulley should be aligned with the center of the belt. Check that the alignment is correct so the tensioner, pulley, and belt all run in the same plane. Angular or parallel belt misalignment can create heat and noise as the belt slips over the pulleys. When it comes to alignment, the internal tensioner pivot bushing is critical. It can wear out over time, which can affect alignment. Misalignment results in belt edge wear as the belt tracks off and rubs against a bracket or other engine component. The second attribute of a tensioner is pretty obvious: tension. Belt tension varies depending on the tensioner's design and also the accessories that are on the drive. The more accessories, the more load, which means the system probably needs more tension. If the tension is not right, it can cause accessories on the drive to be substantially less efficient and could even cause system failure. The final attribute is a big one: damping. Damping is what smooths out the oscillation or torsional vibration. Every time something turns on or off, or the engine fires, there are variations in belt tension. Damping smooths out the tensioner movement. Damping is specific to each vehicle. Sometimes a minimal amount of damping is all that's required. Other times, a tremendous amount of damping is needed. Remember that the damping mechanism is a composite plastic component that will wear over time. Let's talk about springs for a moment. The spring is an important part of the tensioner, including its size and shape. At Gates, we use a round spring in our tensioners. The round spring is designed with a gap in the coils to eliminate coil-to-coil contact. This ensures a noise-free and consistent tensioner operation. The vast majority of OEMs choose a coil spring over a flat spring design due to superior function and operation. Finally, the tensioner operates in a limited range between the free arm stop and the load stop. In most cases, a new out-of-the-box tensioner is in the free arm stop position. The load stop position is the position the tensioner is in when you put on the belt. The tensioner usually operates in the middle of the range and doesn't vary much. As the belt wears, it elongates a little bit, and the tensioner will take up that slack to a point. When the belt wears beyond that, the tensioner moves outside the operating range and can wear excessively or fail. So that's why it's really important to check the belt with a belt wear gauge to see if the ribs are worn. It's best to replace the tensioner, belt, and pulleys at the same time, as they all wear at about the same rate. Thanks for watching. Sign up for our Auto Revolutions e-newsletter at gates.com/signup to stay up to date on all things Gates Automotive.